Is it going? Yeah, it is. Okay. Hi, Ms. Jensen. So I'm going to talk about inverse trig functions with the triangle. I don't know if this is one of the topics, but it said inverse trig functions, and this is what I know how to do, so I'm going to explain it to you. Shit, I just drew a triangle. Okay, so say we have a problem like so. So we have tangent of the inverse sine of x. So what you first have to do, so you know that sine, like you have your SOHCAHTOA, right? So you have, I'm going to write this at the top. SOHCAHTOA. So that means sine is equal to the opposite of the triangle over the hypotenuse of the triangle if this is theta. So this would be adjacent, hypotenuse, and opposite. So sine would be opposite over hypotenuse, cosine would be adjacent over hypotenuse, and tangent would be opposite over adjacent. So we know it gives you that sine of x, sine equals x. So that means that sine is opposite of hypotenuse, so the opposite must be x. And so x over what equals x? 1. So now we have x and 1. And so using the Pythagorean theorem, that we can set that equal 1 squared equals x squared plus a squared. Then solve for a. So you have 1 minus x squared equals a squared. So the square root of 1 minus x squared equals a. So here we have our fully labeled triangle from what we're given. So what's asking us to find is the tangent of the angle whose sine is x. So we have the sine, we've just figured that all out. So tangent over here, we have opposite over adjacent. Sorry, my phone is going crazy. So opposite over adjacent, so that would mean if this is theta, this is opposite over adjacent. So that means that the tangent of the angle whose sine is x is equal to x over the square root of 1 minus x squared. And that's our whole fucking thing right there. Cool? Makes sense? I'm going to do another one just because this is so much fun. And this video is only like 3 minutes long. Probably shouldn't have written an expo marker. Whatever. Okay, so let's try this again. So say we have the secant of, let's say, of the inverse cosine of the square root of 3 over x. So here you have it, our thingy. So what's asking us to find is the secant of the angle whose cosine is negative, or the square root of 3 over x. So first we've got to draw our triangle and label the right angle and theta. All of these have to have a right angle, by the way, because Pythagorean theorems wouldn't work without them. I'm going to go ahead and write my SOHCAHTOA just because it helps. I haven't done one of these videos in a long time. Okay, so secant, I already write my SOHCAHTOA, so secant is equal to 1 over cosine. So secant equal to 1 over cosine. Okay, see, I wrote my SOHCAHTOA, and so I wrote this. So that means that the secant is 1 over cosine. So the secant would be hypotenuse over adjacent. So secant equals hypotenuse over adjacent. So that means hold on, I should probably do cosine first. So cosine is adjacent over hypotenuse. So we have this, and we should set this, right? So cosine is adjacent over hypotenuse. So adjacent would be the square root of 3, and then hypotenuse would be x. And then you've got to use Pythagorean theorem to find out the rest. So x squared equals square root of 3 squared plus opposite squared. And then figure that all out. So it's x squared minus 3 because the squared and the 2 cancel. The squared and the squared cancel. And there's probably supposed to be an absolute value, but I don't care. Square root of that, and it gives you opposite. So now you have the square root of x squared minus 3. See how that works? I have my full triangle from the information that it gave me. So here is the angle whose cosine is the square root of 3 over x. So now it's asking me to find the secant of this angle. So that's easy, we just found all the stuff. So secant, I just proved that secant is hypotenuse over adjacent because it's 1 over cosine, adjacent over hypotenuse. So hypotenuse over adjacent would be x over the square root of 3. So you literally just flip it for secant. Probably should have picked a better thing. Does this make any sense? Perfect. I just explained to you inverse trig functions very easily. Now I'm going to go to bed. Bye, Miss Jensen.